Good afternoon. My name is Max Moldovan. Today I will be giving a talk regarding the comparison between virtual machines and physical computers within the secure unified research environment. The objective of my talk is to identify the areas for improvement within the secure unified research environment. And I will be doing it by objectively comparing virtual machines against physical computers. SURE, which is short for Secure Unified Research Environment, is a computing environment located in Sydney, Sussex Institute. SURE provides computational resources and secure infrastructure in the form of virtual machines. Importantly, SURE is the only Australian government-approved secure platform for analyzing unit record level sensitive data. To perform the comparison, I will be using 4 machines. 2 of them are physical machines, standard laptop, a standard desktop, 2 boxes on the top, and 2 machines in the form of virtual machines. Virtual machine 1 with 16 gigabytes of memory and 2 virtual cores, and virtual machine 2 with 90 gigabyte of memory and 6 virtual cores. For comparison, I will use a standard test, which performs a set of operations on tabular data sets. The code for this test is freely available online. The form of a tabular data set to be used is as shown on the screen. And it contains 9 columns. 6 of them are IDs, and 3 of them are numerical information. And the size of this data set can be varied, but requesting different number of rows within the data set. Computations will be performed using Air data table package, which arguably is the best package for dealing with tabular data. So let's see what is the output from a single test run. This test is applied for a relatively small data set of 10 million rows, which takes 500 megabytes in memory, and the top line represents 2 runs across 2 available cores on virtual machine 1, and so on. And as you can see, the laptop has got the most cores, but it should be noted that only 6 CPUs are available on these machines, and each CPU got 2 threads each, while the desktop having 4 CPUs is running on a single thread for each of them. From this picture, you can see that with increasing the number of cores for computations, the computational time reduces, which is y-axis, and while reduction is substantial, if you add the second core to the first one, the improvement in computational time becomes slower when the number of cores increases. Now I move to the next limit, and the next limit I set as 15 gigabyte data table, and this data table pushes the memory of virtual machine 1 to the limit, and as you can see, virtual machine struggling to implement the task, while the rest of machines are performing pretty well. So virtual machine 1 is out of the race. I move to the next limit, and this limit is set as 30 gigabyte data table, which I expect to push two physical machines to the limit, since they have only 32 gigabytes of RAM. And indeed, you can see that desktop, which is the top green line, is performing much worse than the laptop red line, and surprisingly, laptop is performing worse than the virtual machine 2, which I wouldn't expect. And now virtual machine 1 and physical computers out of the race. So we have left only this virtual machine 2, and we still can push it to the next limit, and supplied 1 billion rows dataset, which takes 50 gigabyte in memory. And as you can see, by adding only a few additional cores, can improve computational times almost 3 times. Now I suggest I move to the real task, and just recently we published a paper, and the computations for this paper took us about 12 years of a single core computational time. And of course, the facility required for this type of computations should be in the form of high performance computing. And as you can see, we could access a pretty decent machine in summary. And we spent around 3 to 4 months real time and 30 days non-stop computations. And of course, at this point of time, I don't see it's possible on current Shore offerings. I conclude. Surprisingly, virtual machine performs not much worse than physical computers, and even outperforms physical computers when data sets become larger. This brings me to recommendations, and from my subjective point of view and my greedy demands, I would recommend to provide 6 to 12 cores and 64 gigabyte of RAM for standard users account. And for intensive computations, the facilities should be close to high performance computing facilities, which should be up to 512 cores and up to 1 terabyte of random access memory. Obviously, this kind of resources cannot be provided on a continuous basis. Therefore, I see it as shared resources across multiple users. I thank you for your attention, and if you have any questions, here is my email, and I'm happy to answer your questions. Thank you.